Okay, well, we digressed a little bit to translate from this form to this form because people were a little confused by that. But now, forget the digression, there's the equation, right? So, as we just said, somebody just said that, we're going to find a common denominator and multiply by it, right? Because that's what you do when you got denominators. You don't want to mess with denominators. There's a little caveat with the denominator. When you do that, you have to exclude from the domain of your solution any number that makes one of the denominators 0. So I'm going to kind of write that down, but I'm not going to stress it right now. We'll just go to the algebra operations. And common denominator is x times x plus 4. You just multiply your denominators, right? Mm-hmm. Now, often there's a lower common denominator. It's going to be simpler if you find the least common denominator. Okay? But if you find a common denominator that's bigger than it needs to be, it can still work. It just means you're going to have to do a few more steps in your solution. So it's not a big deal. Okay, so multiply by x times x plus 4 multiplied by 3 over x plus 6 over x plus 4 equals x times x plus 4 times 0. Didn't leave myself as much room as I thought I was going to have. Can we see that? Mm-hmm. Okay. Well, what are we going to get on the right-hand side?
0.
Well, we're multiplying by 0, so we got a little more room for the left-hand side. Okay, of course, we kind of want to keep our equal signs aligned, but I never do. Okay, what do we do on the left-hand side?
Distributive property?
Distributive. So it's x times x plus 4. No, actually, I'm going to do this. Times 3. We want to keep things factored. We don't want to multiply stuff out until we can't simplify it any further. Because you see, if I make that an x squared plus 4x, I might not see that I can divide the x into the x. Right? That makes sense? Okay? And then it's plus what? Okay, and we see that we have an x here and an x here. We have an x plus 4 here and an x plus 4 here. But we don't start crossing things out. I do not like crossing things out unless you've demonstrated that you know exactly when you can do that and when you can't, which 80% of people in a pre-calculus class don't. Okay? So I come back to the rules rather than the tricks. Rather than doing things by the way they look, doing things by the way the rules dictate. So what I can do here is I can write this as x over x multiplied by x plus 4 times 3.
That's 1 times.
Yeah, which is just x plus 4 times 3. Which is what you get if you crossed out this x and this x, but if you start crossing things out, you're likely to cross this one out too.
No.
And maybe you'll cross this one out here and this one out over, well, there are no x's here, but you might if they were. Indiscriminately crossing out x's because you don't understand the very simple rule, okay? You end up making errors. And you don't understand that rule because you've never been asked to understand that rule. You just cross things out. And you're given rules for when you can cross them out, but you forget them because they don't get reinforced. Okay? So I don't like cancellation until you really understand the rules. Okay? This is what it amounts to. This is cancellation. but I'm not calling it that, and I'm not crossing things out. Okay? Then we can write this as x plus 4 over x plus 4 times 6x. Still equal to 0. Okay? Now this is something we talked about from the first day of class, okay? Or at least from the second day of class. So you might go back and review some of your work and some of your notes on that. Now, so I don't have as much room as I used to. I wasn't sure I had enough room to do it anyway, but I'll extend down here a little lower. Okay? Well, x over x is 1, so that's just
Bless you.
Thank you.
x plus 4 times 3 plus x plus 4 times 6x equals 0. Right? Now, can you do the rest from there?
No.
I
Why you got the x
think
plus
you're
4
right.
right
There's no x plus 4. What'd y'all write that down for?
She said,
Yeah, I was already looking at it and saying, how did that end up quadratic? Because I knew this, I made this up. I made this problem form up so that it would be linear. And all of a sudden it was quadratic. So I was starting to see what I'd done. But y'all saw it before I did, and that's good. Okay, so now we have this. Now that's an easy equation to solve, right? So I'm just going to write down et cetera. So the bottom line is, if I identify my common denominator, multiply it through, and don't screw up a cancellation. In other words, use the rules. It's an easy equation. Okay? So you got to know to do that. So the first problem was just a very simple linear equation, but yeah, I mean, you had to use a distributive law on both sides. Okay? But it's one that I think everybody can easily solve. Second one turns into one that's even easier than the first one, but you got to do a little work first. Okay? What would happen to this equation if I had an x squared down here? Because that comes up a little later.
Everybody would have been mad.
quadratic.
Yeah, you would end up with a quadratic equation, right? Okay? Now there's this other thing people do called cross multiplication, which I dislike almost as much as cancellation.
I'm not doing it.
Although if you do it in the right form, it's a little less prone to error, so I don't dislike it quite as much. Okay? But I talk only about multiply by a common denominator, because that covers it all. Okay? The other things are shortcuts that don't clearly follow any rules except their own. Okay? I want to stay with the rules because it's the safest place to be. So if you don't use the basic rules, if you use cancellation or cross multiplication or anything like that, don't screw it up. Okay? Because I'm unsympathetic.
Yeah.
Rules are meant to be broken.
Well, I mean, I'm personally sympathetic, but in grading, I penalize that hard. Okay?